Okay, so question number 3. What is the Lewis structure for N2O4? Okay, so first let's find out the total number of valence electrons, since this will help us write out the Lewis structure for this compound. So nitrogen has 5 valence electrons, and since there are 2 nitrogen atoms, we multiply this by 2. And oxygen has 6 valence electrons, and we multiply this by 4. So this gives us a total electron count of 34 electrons. Okay, so now let's try to draw a skeletal structure. We have our 2 nitrogens that will be bonded together, and we can show each nitrogen having 2 bonds to the oxygens. Okay, so let's see what happens if we just drew in all of the lone pairs on our oxygen atoms. Okay, so if we look at all of the electrons that we have so far, where each bond contains 2 bonding electrons, then we can see that we have our total of 34 valence electrons. But our nitrogens don't have a full octet yet. So if we brought down these pair of electrons for 2 oxygens to form a double bond, so let's just erase these and make this a double bond, then you can see our nitrogens have a full octet. And we can also calculate the formal charge of each of these atoms. So formal charge is equal to the number of valence electrons minus the number of non-bonding electrons minus the number of bonding electrons divided by 2. So first let's calculate the formal charge of a single bonded oxygen. So oxygen has 6 valence electrons, and there are also 6 non-bonding electrons on our oxygen atom. And since there's only a single bond, we have 2 bonding electrons divided by 2. So each of the single bonded oxygens will have a formal charge of -1. So let's draw in the charges. And let's also calculate the formal charge of a double bonded oxygen. So again, there are 6 valence electrons, and this time we have 4 non-bonding electrons. And since there's a double bond, we have 4 bonding electrons divided by 2. So each of the double bonded oxygens have a formal charge of 0. So now let's calculate the formal charge on our nitrogens. Nitrogen has 5 valence electrons, and there are no lone pairs on either of these nitrogens, so we just write 0 for non-bonding electrons, and each nitrogen has 4 bonds attached to it. So we have 8 bonds in total divided by 2, which gives us a formal charge on nitrogen equal to +1. So we can draw in our nitrogens having a +1 charge, and if we were to add up the overall charge of our molecule, then you can see that they cancel each other out. Since we have 2 negatives and 2 positives, we have an overall charge of 0 for our molecule, which is good since we know we have a neutral molecule. Okay, so this is the correct Lewis structure for dinitrogen tetroxide. And the junior tutor said, when we draw a Lewis structure, we first write the possible skeletal structures of the molecule. This shows how the atoms are arranged. After this, we count the number of valence electrons present in the molecule, and we distribute this in the skeletal structure as dots. We want that each atom achieves the octet rule for stability. The resulting figure is the Lewis structure for the molecule. Okay, so they have the correct skeletal structure and drew in all of the bonds and all of the lone pairs to get the final answer. Okay, so the charges weren't included, but I'll just say that down here. So this solution is correct. Okay, so I also just added that the single bonded oxygens will have a formal charge of -1, while the nitrogens will have a formal charge of +1, making the overall molecule neutral.